Hi guys, today's lesson is on macromolecules, more specifically lipids. So just a reminder, there are 4 types of macromolecules. They are carbohydrates, lipids, proteins, and nucleic acids. Make sure you take notes and prepare any questions you have for me for tomorrow. Lipids are the second type of macromolecules that we'll be discussing in class. The first type was carbohydrates, which was the previous video. Lipids are made up of carbon, hydrogen, and oxygen, but mostly hydrogen atoms. They're considered as long-term energy sources for the body, and they help with the absorption of vitamins. They are an important part of the cell membrane, and examples would include butter, salad dressing, oils, and egg yolks. There are 3 types of lipids. The first type are the fats, oils, and waxes. They consist of saturated and unsaturated fats, and also include waxes that are found on leaves, kind of like in the image above. Your second type of lipids are your phospholipids. They're part of your cell membrane, and as you know, they have that hydrophilic head and the hydrophobic tails. The third type of lipids are the steroids. An example of steroids would be cholesterol. Your smooth endoplasmic reticulum is the organelle that's responsible for all the lipid and steroid synthesis. Oils and fats are made up of triglycerides. A triglyceride has 4 parts. The first part is a glycerol, which is a 3-carbon molecule with a hydroxyl attached to each carbon. And it's also made up of 3 fatty acids, which are just long chains of carbon and hydrogen with carboxyl groups at one end. The image below is of a triglyceride. You won't be expected to memorize how to draw this triglyceride, but you should know what it looks like and also what are the parts that make up a triglyceride. There are 2 types of fats. You've got saturated fats and unsaturated fats. Saturated fats would be animal fats. They're generally solid at room temperature, and they're solid because they have a single bond of carbon, so all of their carbon atoms are bonded together with just single bonds. Whereas your unsaturated fats, kind of like your vegetable oils, these are liquid at room temperature, and they're liquid because they have a double bonded carbon. So if you're looking at the image below, you see that little bend in that molecule, and that's because of the double bonded carbon. Here's a quick question for you. Saturated or unsaturated fats? Butter and olive oil. Which is saturated and which is unsaturated? The clue would be in the images below. What you'll notice is the butter have all single bonded carbons, whereas the olive oil has a double bonded carbon. Based on that evidence alone, you should be able to differentiate between the saturated and the unsaturated fat. Phospholipids are the second type of lipids, and as you know, these are found on the cell membrane as part of the phospholipid bilayer, and it consists of a hydrophilic head and hydrophobic tails. The phospholipid bilayer, as part of the cell membrane, helps the cell control what goes in and out, and it also separates the intracellular fluid with the extracellular fluid. Steroids are the third type of lipid, and an example of a steroid is cholesterol. Cholesterol is one of the chemicals used by your body to make certain hormones. The male and female sex hormones are made from this chemical. Without cholesterol, the difference between sexes would be less obvious. What most people don't know is that 80% of the cholesterol your body needs is produced by the liver, and the rest is obtained through your regular diet. If cholesterol combines with other fats, it can form a plaque that may block blood vessels, and that will lead to heart disease or circulatory problems. Reduced blood flow through the vessels means less oxygen is transported, and as a result, tissues can die from the lack of oxygen and nutrients. So you can only imagine how dangerous it would be if plaque were to build up in the heart muscle. The image there shows you the difference between a normal artery and a clogged artery. There is a difference between your good and your bad cholesterol. Your good cholesterols are your HDLs, your high-density lipoproteins, and your bad cholesterol are your LDLs, your low-density lipoproteins. Your HDLs, which are the good cholesterol, they pick up cholesterol and take it to the liver for removal. That's in the first image there. So there is unrestricted blood flow. Whereas your LDLs, the bad cholesterol, they pick up cholesterol and deposit it on the artery walls. So if you're eating a lot of food that have bad cholesterol, then it will result in that fatty plaque buildup and will result in clogged arteries. There are different factors that affect blood cholesterol level. They are family history, age, gender, eating habits, body weight, shape, and level of physical activity. We're going to go into these factors into more detail in class. And that wraps up our lipids lesson for today. Tonight, what I'd like you to do is to ask your parents and see whether or not they have high cholesterol levels or low cholesterol levels.